Congratulations! You were just elected mayor of the new town Whoville. This means that you get to build your house anywhere on the blank grid that is your new town. But you're picky. You like the light in your house to be just right. This means that other houses can't be built blocking your south or west facing windows. So if you randomly build your house anywhere on this blank grid, what is the expected number of houses to be built in your new town? For example, if you were to build your house here, then 20 houses would have been built in your town. To start, let's try and figure out what we are being asked. We need to find the expected number of houses built on the grid. Essentially, this means if this activity were repeated hundreds of times, what is the average number of houses built going to be? Luckily, we don't need to repeat this hundreds of times. The expected value formula will tell us the return after a certain action is performed. In this case, the action is randomly building the mayor's house on the grid, and the return is the number of houses built according to the mayor's condition. The expected value formula is the probability of an event multiplied by the number of tries. In this situation, it is the probability of an action occurring multiplied by the total number of houses that could be built. Let's first find the probability of each action occurring. For starters, an action is not the house being built, but at which spot. So what are the chances that you build your house here? Well, the probability formula is the number of good outcomes divided by the total outcomes. This is an 8x8 grid, which means that there are 64 total outcomes, and we are looking at one single one. This makes our probability 1 out of 64. Now for the tricky part. What is the total number of houses that could be built on the grid? Let's make this simpler. What if there was only one row? Then what would the total be? If the mayor's house was here, that would be 1. Here would be 2. Here would be 3, and so on and so on. That would give us a total of 36 possible houses in only one row. Cut it. Okay. Now we've added the second row. It's going to be the total from the first row plus what would happen if the mayor's house was placed anywhere in the second row. If it was here, that would be 2 houses. Here would be 4, and here would be 6, and so on. Excellent. That 4 though. Now let's look at the third row. We're going to have added the previous 2 rows, and what would happen if the mayor's house was placed here, 3, here, 6, here, 9, and so on. Have you noticed a pattern? Let's line them up. Notice how the second row is 2 times the first, and the third is 3 times the first. The other rows are going to follow this pattern. But before we move on, we can simplify the first row to be 36. This leaves our expression as our row number times 36, plus the next row number times 36, and the next one, and the next one. Now our expected value formula is going to be our probability 1 over 64 times the formula that we just came up with, which is going to leave us with 20.25. So we can expect about 20 houses to be built. Now, you've chosen to put your house here. This means that the grid is completely full. What are the chances that you pick 2 houses that are side by side? Like this one and this one. Or this one and this one. Like before, the probability formula is the number of good outcomes divided by the total outcomes. Let's start with the easier one. How many ways are there 2 houses on the grid? That's easy. 64, choose 2. When we start to look at the grid, we notice that some squares have more adjacent squares than others. We definitely have to take this into account. There are 36 squares with 4 adjacent, 26 with 3, and only 4 with 2. Following this route would tell us that the number of good outcomes is 36 times 4 plus 24 times 3 plus 4 times 2. But if I were to count this square and this adjacent one, that's the same as counting this adjacent square to this one. So it really counts everything twice. To fix this, we will divide this by 2. So our probability now becomes the number of good outcomes divided by our total outcomes, 64 choose 2. Our good outcomes end up giving us 112, and 64 choose 2 is 2016, which will give us the grand total of 1 over 18. This means that there is a 1 out of 18 chance that you would randomly select 2 side-by-side squares on our grid.